Alrighty. Now, I mean, we're getting to the point where it is total end of the year review. So, I mean, the real question is, how confused are you? And then, furthermore, if you're confused, what are you doing about it, right? First of all, you're watching the video, which is phenomenal, right? I mean, you're doing everything on your end to get better. So now it's all on me. Here we go. A, 5 2/3 minus 3 4/5. Now I'm going to turn subtraction. Yesterday it was decimals. Now we're going fractions or mixed numbers. So remember, it's just like when we were adding with mixed numbers. You have the first quantity is 5 2/3. It's what you have, so it goes on top. And then what you're taking away from it goes on the bottom. You look at the fraction part. Look at the name of the fractions. Are they the same? No. So 5 can turn into 5 or 10 or 15. I'm going to choose 15 because it's the first thing that both 3 and 5 can go into. It's called the greatest or the least common multiple. How many 3's going to 15? 5, right? 3, 6, 9, 12, 15. That's 5 of them. So therefore, everything gets multiplied by 5 moving over. So this turns into 10. So 10 15ths is equal to 2/3. Perfect. And then how many 5's make 15? 3. So 4 turns into 12. 4/5 is equal to 12 15ths. Now, I have new fractions that have the same name. Here's the other issue. If I only have 10 of them, I can't take 12 away. So I have to go to my wholes and be like, I need to break one of you. So now you're 4 wholes, and then the 5th whole's coming over, and I'm going to break it up. Now this whole is going to be, well, I want it to be more 15ths. So one whole is worth 15 15ths, and I'm going to give it to the 10. So I have enough to take 12 from. So I have 15 and 10. I have 25 15ths. Yes, it's improper, but that won't last for long because I'm taking 12 away from it. 25 minus 12 is 13. So 13 15ths is left. And then I go to my wholes and I say 4 minus 3 is 1. If you remember how difficult this was in the beginning of the year, just know that I'm a little bit sad. This time of the year, I'm always a little bit sad because next time I teach, I'm going to get a whole bunch of confused faces again. Like, what? What are you doing? That's so confusing. Well, not right now because you guys have mastered it, right? It's been a long year of mastering, but you guys are there. All right, looking at B, it's a totally different thing when you're going to multiply by mixed numbers. First of all, they don't have to have the same denominator, right? Adding and subtracting, they do. Multiplying, they don't. So the first thing that we have to do, though, is we have to take our, I'll go on the screen for this one. We have to take our mixed number and actually just turn it into a numerator denominator. How do we do that? We turn our whole into 3/3, right? This is worth 3/3 plus you have 2/3. So this whole thing is worth 5/3. And then I'm going to multiply 5/3 by 5 wholes, and 5 wholes is the same thing as 5/1, right? So now I have 5 times 5, which is 25, and then 3 times 1, which is 3, because the way you multiply fractions is you multiply numerators and you multiply denominators. Now this is an improper fraction. They want to see how many 3's are in 25. Why? Because 3/3 is equal to a whole. So 3, 6, 9, 12, 15, 18, 21, 24. There's 8 of them. 8 of them made 24/3, so we still have 1/3 left over. The entire answer is 8 1/3. The entire answer is 8 1/3. Coach Williams ordered 42 uniforms for the players on the football team. The total cost of the uniforms is $5,796. How much did Coach Williams pay for each uniform? Well, we have total $5,796. 5,796. And we are going to divide that by 42. I don't know if I'll have enough room here, so let me rewrite it. Actually, I'll just use another piece of paper here. There we go. So the first thing we want to do is say, well, we're counting by 42s, and how many 42s are in 57? 1, 1. Is there anything left over? Sure. 42, take it away. There's 15 left over, bring down the 9. How many 42s are in 159? Ooh, this is a disgusting question, right? I'm going to guess by counting by 40s. 40, 80, 120, 160. Ooh, it's not going to be 4 because 40 times 4 is 160, which is too much. And this is even more than 40. So it's got to be 3. So over here, I'm going to see what 42 times 3 is to see what's left over. It was 126. So I'm going to put my 126 here. 9 minus 6 is 3. 5 minus 2 is 3. I have 33 left over. Bring down the 6. So 42 times 3 was 126, which is less than half. I'm going to guess it's going to be 7, because if this is less than half, when you double it, it's close to half. It's close to it. I'm going to just guess 7. So I'm going to figure out what 42 times 7 is. 7 times 2 is 14. 7 times 4 is 28, plus 1 is 29. Ooh, that's 294. Could we go one more? Sure, maybe. Let's try. So let's see what 42 times 8 is. Hopefully it's 336. 8 times 2 is 16. 8 times 4 is, 8, 16, 32. Plus 1 is 33. Check it out. We figured out that 42 times 8 is 336. So how many 42s can we take from 336? 8. Is there anything left over? Nope, it hit perfectly. So the answer is exactly $138. $138. That was a hard question, wasn't it? Double-digit division. Yuck. Get rid of all that mess. All right. Now we have 505 divided by 1.5. So I'm going to write it down. 505 divided by 1.5. Am I allowed to have that decimal? I can't have a decimal on the that I'm counting by. So I have to get rid of it by pushing it over. But whatever you do to this side, you have to do to the other side. It's like a teeter-totter. If I do it, oh, now it's not even, so I got to do it to the other side. 2. This one doesn't have a decimal. Oh, Mr. Stahl, every number has a decimal. It's just sometimes hidden because it's a whole number, so you don't need to see it. So if you push that one over, you have a new problem. So 15 is going to go into 5,050. Why'd you do that, Mr. Stahl? Well, to get rid of the decimal, you're pushing it over. And you know that's multiplied by 10 to the first power, right? And then in order to keep the answer the same, you have to also multiply this by 10 to the first power, which we did. And that's how we got this problem instead of that one. Now we don't have the decimal in the divisor, so we're good to go. How many 15s go into 5? None. How many 15s go into 50? Ooh, that's 3. 3 15s is 45. There's 5 left over. Bring down the 5. If 3 15s is 45, well, we can't take out any more than 45 again. What's left over this time? 10. Bring down the 0. How many 15s go into 100? Ooh, I can do this one. 15, 30. So I'm going to count by 2s. 30, 60, 90. 6 is 90. Once again, 10 is left over. So the answer is 336 and 10 15ths. 336 and 10 15ths is the same thing as 336 and 2 thirds. I don't know how to simplify like that. Well, if you look at 10 15, they can both be counted by 5s. So what would the original fraction be? Well, 2 times 5 is 10, and 3 times 5 is 15. That's how I got 2 thirds. This one should be a little bit easier as long as you don't get tricked by lining them up the correct way. 5, 9, 4 has an invisible decimal after it. 9 is way over here, 8, 9, nothing, nothing. Addition. 9 falls down, 8 falls down. 4 plus 3, or 4 plus 9 is 13. And then 9 plus 1 is 10. 603.89. And then last but not least, I just have to add all these bags up. So I have 1/4, 1/4, and 1/4. That's 3/4. I have 3/8 and 3/8. 6/8. I have 1/2. And I have 5/8. You cannot add fractions if they have different names, right? I cannot add fractions if they have different names. So 4, 8, 2, and 8. What's the first name they could all switch to? Eighths. 3/4 is the same thing as 6/8. 6/8 is the same thing as 6/8. 1/2 is the same thing as 4/8. And 5/8 is the same thing as 5/8. Cool, they all have the same name, so I just need to add the top number. 6 plus 6 is 12, plus 4 is 16, 17, 18, 19, 20, 21. 21 eighths. Let me make sure that's right. 6 plus 6 is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yep, I like it. How many eighths are in 21? Well, 8, 16, 16, 17, 18, 19, 20, 21. 2 and 5/8. And that is that, ladies and gentlemen. Now, what I would like for you to do, just like yesterday, is I would like for you to work on your homework. Mr. Straw, we didn't get homework yet. No, you did not. But we are going to go over any of these questions, any of these answers at 10:30. You can get a head start now. Here are the problems. I will explain them very quickly, and then I will tell you guys get rocked and rolling. First, you're going to label your paper that you have right now, 1 through 12. Mr. Stahl, where's this in the book? It's not in the book. This was produced by yours truly. You're going to tell me how many cubes are in number 1, how many total cubes are in number 2. Remember, this is the volume, and remember also that I am hoping you don't just count the cubes. Instead, kind of turn these into this kind of problem by counting to measure. This is 2 by 2 by 5. So you just multiply 2 by 2 by 5, right? 4 times 5, 20. Tell me how many edges this cube has. Edges, and it shows you the edge is this guy right here. So you got to kind of use your imagination to figure out how many total edges are there and how many faces. The face is this yellow part. How many faces are on a cube? And then they only give you 3 numbers for these. So you're going to multiply length times width times height in any order, because multiplication, the order doesn't matter. Find the volume of all 3 of these by doing that. And then over here, you're going to read the actual story and you're going to come up with the answer. Raul is building a planter in the shape of a rectangular prism. It has a length of 4, a height of 2. How wide would it be if the entire volume is 24? So you have 4 times 2 times something equals 24. You got to find something. Fred's dog crate is 42 inches long and 24 inches wide and has a height of 30. What's the volume? So here you're going to multiply 42 by 24 by 30. And then the cargo hold of a truck is 3 by 5. The volume is 240. What's the length? Once again, you got the missing length. You have the volume. So 5 times 3 times something equals 240. You got to find something. And then you're just going to tell me, is this an example of length, area, or volume? Is this an example of length, area, or volume? Is this an example of length, area, or volume? And then you're done. At 10:30, come prepared to ask me questions. I will love to help you with any of these problems that you struggled with. See you at 10:30. Bye.